And we are live, NeuroTechX Showcase, applications, software, and hardware. Hey, John. Hey, Brian. How are you tonight?
Ciao, Cristiano. I'm very good, thank you.
Yes, doing well, Chris. Thank you.
Thank you. Thank you. I should say good evening, bonsoir, in the good tradition of NeuroTechX events, especially reminding people that this is started inspired by Morgan Huff, who is hopefully with us tonight. And we say hi. Hi, Morgan. But also we would like to introduce the topic of this evening, which is really exciting about applications. And we have two great guests. We have Redman and Ore Ogundipe, and then they will tell more about themselves. But first, I would like to have a nice chat with our early guests, Brian and John, from the Toronto chapter of NeuroTechX. And then tonight is special to me because we have a bit of an introduction about the inception of the Toronto chapter. And I'd like to give a bit of a background to all the viewers, the audience, of why we are here and what we are doing. I think, Brian, you were the first one before me and John. So when did you start with NeuroTechX?
Chris, thanks. So I started with NeuroTechX in 2015, shortly after NeuroTechX, as it's known as an organization today, was kind of conceptualized and introduced. And the Toronto chapter started shortly after the first three NeuroTechX chapters were established. So I believe Toronto was the fourth of what is now 25 plus chapters around the world. And wow. So it was August or September 2015. So what is that? Past 6 years ago now, I guess, which is remarkable.
It's a long time. And you were involved in event organization, and you had a couple of technical events, but also educational events. Can you tell us more about that?
Yeah, of course, I'd be happy to. So, much like the experience that we're hosting today, and for our valued or cherished community members, those first couple of years for the Toronto chapter were jam-packed with a number of different experiences for neurotech enthusiasts. And I was kind of fresh off of my graduate degree and kind of looking to sink my teeth into a cool neuroscience-related project. And I loved technology, still do. And so I was fortunate enough to find the community of NeuroTechX that was starting to form in Toronto, and kind of took the Toronto chapter under my wings and built a team around that. And then we ran, I think 20 plus events in the first couple of years. And we did a really cool series on EEG from, the hardware through to the software, different applications, much like we're doing today, featuring local speakers from Toronto. We did a bunch of showcase events as well, where we bring out companies to demo their technologies and get the enthusiasts actually playing with the tech. And then, fast forward those first couple of amazingly fun and very busy years of running the events, it kind of culminated in a very large partnership event with We Are Wearables, which at the time was a huge meetup group. We did a really cool neurotech VR crossover style event. Shortly after that, Dano Morrison came on board, who actually has now since gone on to work for Control Labs, which of course was acquired by Facebook. And he's still with them today, I do believe. And so he took the reins of Toronto, and he really oriented that team and that community and focused on a lot of really cool projects. Some of the folks actually here today are some of the kind of OG neurotech TO members. Shout out to Alfredo, I believe, especially, who's been here since almost day one. So we saw really cool projects that developed out of that community, EEG 101 being one that we know and love, and kind of intro EEG app that you can download and kind of play around with your brain signals in real time, and it would teach you all about the signal. And then we had a cool project called Neurodura, which I think has since kind of been deprecated or died, but it was a really cool project. I use it at work all the time, where it was like a Pomodoro.
Like a Pomodoro, yeah?
Yep. But it would use it was like a Muse headband. It would just use your attention levels to trigger whether or not you were needing a break, or if you'd be in a focused state. So really cool projects came out of that. And then,
kind of like what the Neurosity is doing now, eh?
Yeah, exactly.
Kind of like what the Neurosity devices are doing. Neurodura was ahead of its time.
It's a good point, for sure. Maybe there's something to that. We could trace the lineage, but it was remarkable, really. So much innovation at the time, really cool projects coming out of it. Some that have, of course, carried on to today. And, both you, Chris and John, have been instrumental in the Toronto chapter as well, and kind of getting a lot of the projects underway, again, bringing these events back to our community members, most recently, especially online with COVID. And so it's really nice to see kind of how far the chapter community has come. And we're seeing so many folks from beyond Toronto as well joining and getting excited by what's happening in Toronto. So it's all good.
That's true. And it's one of, if you like, the silver linings of the pandemic, that we're all global, and then we see people from everywhere. Once upon a time used to be only live events, and now the connectivity expanded globally, and then it's a little bit the footprint of NeuroTechX, that is a global organization, and we cover different countries, and we wish to have more countries covered by community leaders that would like to start over, and there is funding for that. So we put a call out there. If you want to start in your own countries where the chapters are not there yet, there is an opening. And thanks, Brian. This was golden. And then one of the, I think there is a code base on Github regarding EEG 101. And correct me if I'm wrong. One of the other interesting projects that started that is already available for free for everyone on the code base on GitHub is Eeg Notebooks. And I know for sure, surprise, surprise, that John is working on that. John, is that true?
Yeah. And like smooth segue, like silky smooth. Because the connection there is that this project Eeg Notebooks, which I can talk at length about. I won't talk at length about, but I'll give a few comments right now. Like that, one of the forming aspects of it was just when I got involved with NeuroTechX and the Toronto chapter, around about that time Brian was saying, like 2016, and it was kind of like we really knew that we needed. Well, okay, the sequences roughly, and props to Alexandre Barachon as always, who is really like the originator of most of the components of Eeg Notebooks, and it's basically his project that we're taking forward. And then, but the idea is, we want to do EEG. The way I phrase it, people use different terms. Some people talk about BCIs. My background is cognitive neuroscience, and I see Eeg Notebooks as a tool for doing cognitive neuroscience, but it's not just that. But let's, for present purposes, say it's a way of doing cognitive neuroscience outside of the lab, right? So on a laptop with a mobile device, and when we were putting together the components of it, like initially it was this library called MuseLSL. Everything was in MuseLSL, including the kind of visual experiments and so on. And then we realized, or particularly kind of Dano decided that the cognitive neuroscience stuff basically in MuseLSL should be pulled out and become its own thing, and then MuseLSL should really just be purely this library for kind of getting data streamed and saved and so on, which is a more general but minimal problem. So that was kind of when Eeg Notebooks was born. Essentially, was like the like mitosis of of MuseLSL, and then and it's taken its own trajectory. It kind of has extended much beyond just supporting Muse systems, which was that for a long time. But the idea is that you can do cognitive neuroscience experiments sat at your laptop with a $200 EEG device. And when we were doing that split, I have these like really vivid memories of hanging out in various coffee shops in Toronto in the summer with EEG band on my head, and with Dano in particular, and we were like just working on getting this thing working.
That's the effect of coffee on the brain.
It was all kinds of fun, but we probably looked kind of curious because we were like very focused coding, like, okay, stuff's not working, stuff's working, stuff's not working, stuff's working, scanning my brain, having a coffee, getting another coffee, coding, scanning my brain, and so on. It was more or less like that solid for about 3 months in the summer. It was 2016, I think. And then where it goes from there, so Eeg Notebooks is like a growing entity. We think it has a lot of value in the general space of mobile EEG and kind of cognitive neuroscience. And we have some big announcements which will be coming soon. I think Ori will mention them a little bit. Ori, by the way, who's one of our speakers, is a very active and valuable part of the Eeg Notebooks core development team, and he brings a lot of software engineering chops to the group. So I'll wrap it up on that. But yeah, like what I thought is an interesting like general point here, right, is the nature of neurotech software projects, right? So and the value of them, right? And it's not just neurotech; it's like personal projects in general. They don't even need to be software, right? But just specifically in terms of those things, right? I would say the value of there are a few different things that you could say define the value of an open source software project, like for you and for like people, plural. The obvious one is, let's say you had, it turns into a piece of software that is around for a while and lots of people use, and that's the obvious and kind of the primary thing that you want. But there are other things as well, right? There can be kind of evolutions, right? So I described before, like there's this evolution of Muse-LSL into Eeg Notebooks, and it's possible Muse-LSL will be kind of superseded by BrainFlow, and then so on and so forth. And like Neurodura as well, that, you know, it kind of played its role in feeding in, kind of seeding the ideas for other projects. So I think some open source, you know, software projects, like they really do go the distance, let's say, and they become like long-term tools that have a wide user base and have a real footprint. And then there's other ones that they have more of a, you know, proprietary kind of a subtler role in the development of some ideas and some individuals and some communities, and all those things are good, right? So
I think John is worth to mention on the cue of what you're saying, that Eeg Notebooks is also a stimulus delivery software. It's not only, you know, it's a code base that connects you with different, you know, hardware head-mounted devices, but also has the laptop, like you mentioned, monitor presentation device embedded in the code base, which is Python based, if I'm not wrong, and that's added value
I mean,
top of
it's
the code base.
The way that I have, so I can give people a link, and I have like an hour-long talk on this, but there's a slide somewhere that I kind of represent what really Eeg Notebooks is about, and it's basically the glue between three things. It's between an EEG stream, right? So we have two external libraries that we kind of pull EEG streams in from. It's a visual stimulus presentation, which is the PsychoPy part, which, as you were talking about, and that's kind of the cognitive neuroscience part, like visual system, auditory system, etc. And then the third part is the analysis. And we have like a minimal amount of analysis functionality, but the entity and the kind of, you know, value proposition of Eeg Notebooks is really like the glue and the combination of those three things, which there actually aren't any other software tools really still out there that do all of those things. You tend to be one and the other, and then it's on the kind of user side to pull them together. And when you're trying to cater to a user group where you want to make things easy to do, then obviously it's better if you can package them for people so they don't have to learn those things separately.
Exactly, and that's so special, especially now that people tend to be working from home and doing their neuroscience from home, to have availability of these comprehensive tools to run their own lab at home, right? And the code base is totally for free. So thanks, John, for contributing that. We love you, we appreciate you for that, and this is great that you have made it available for everyone. And also, you were mentioning Muse-LSL and then BrainFlow as a, you know, successor of that. It is of the latest, the new that BrainFlow integrates the Muse devices without the need of the dongle. So.
Oh, really?
Yeah, it came out recently, I think.
I didn't know this.
That's great news. So I want to give the premiere here.
I literally was on Amazon and bought 4 of those things today.
I'm also swimming in dongles.
Why did you not tell me this 5 hours ago, Chris? Anyway.
I should have told you. Anyways. Okay, guys. No, it's such a pleasure to know about this latest and greatest about the code bases and also what's happening with BrainFlow. But let me tell you a little bit the latest and greatest about NeuroTechX. And I think, what I want to do is share my screen and tell you more about the landing page of NeuroTechX, because that describes our community and our mission and vision. I hope you can see the community page, landing page. Look, we have about, now this is not up to date, we have about 13,000 members that are constituted in the community, and the staple values are community, education, and networking. And I'd like to remark that we do have a Slack channel that everybody is free to subscribe to, and you can join us either by clicking this button or clicking the button here below in the Crowdcast is the green button that you see there. We do have a hardware hub, and we do have a job career opportunities section here. Please consult that if you're looking for a job. And there are so many available jobs there, and this is a growing section of the site. We'd love you to have a look at that. But I stop sharing my screen. Without further ado, I would like to introduce our guests, and we say for a moment bye to Brian, and stick around in the background to help us with the good work that you're doing. And I'd like to invite Ore now on screen, and let me see if he's available. So Ore Ogundipe. Hi Ore, how are you?
Hey, how's it going?
Good. Nice to have you.
Hey, Ori.
Thank you for having me.
Good to be seeing you at a reasonable time for you, Ori. Usually, let me explain that. Do you want to explain
sure.
that,
I mean,
Ori?
John and I, we mentioned that we collaborate on Eeg Notebooks. So usually when we meet, it's around like 7 a.m. PST, like 10 a.m. Eastern time, because obviously that's the only time we can all get to like work together. So
yeah. You're in Vancouver.
Yeah, because we have people in North America, East Coast, West Coast. We have people in Europe. It's not just us being nasty to Ori with the timing. Like it kind of is the only time that works. But he gets the delight of getting up at 7 a.m. to see my face.
It's a honor, John. What are you talking about? Ore, you have a lot of headsets today.
Yeah. I mean, one is the Neurosity headset, that's the crown, and then the other is like a headphone so that you guys can hear me a lot clearer. So I'll probably talk a little bit more about my experience playing with Neurosity's devices and other EEG stuff in between the talk.
Sounds good. And you're in Vancouver, and I love your avatar on LinkedIn. Yeah,
thank you.
You have to tell me what application that you use for that. It's really brilliant.
Oh, I got a friend I commissioned it actually. So he actually did I told him, oh yeah, I have this headset, put something on there and then get my face going. So yeah.
Fantastic. Can I share your LinkedIn account here on the chat?
Yeah, sure, that's fine.
Here you go. We already have one question. We better take it off. Okay. Let's maybe start with you have a presentation and a demo, I believe, tonight.
Oh yes, I'll probably be switching back and forth in between. The flow is really just present and then at the same time touch on whatever things I need to share my screen on. So yeah, let me go ahead and get into it. Also, feel free to interrupt me if you have, questions or stuff that's coming up. I may not be looking at the chat, but I'll be listening for your voices in between.
Sure, we're good at interrupting.
Awesome. Well, hi everyone. Chris just did a little overview of myself. My name is Ore Ogundipe, and today I'll be talking about my journey in neuro. Well, first thing is obviously to give a little backstory about myself. There's a link to LinkedIn, but I mean, there's not this much detail in the LinkedIn itself. But I, for my day job, obviously work at Microsoft on the Insights and ML platform. So essentially working on how we can use data to drive growth for the business itself. and specifically on, machine learning and, delivery at large scale, petabytes and that size of data. Over my career, I've really kind of jumped around, started as a regular software engineer, but kind of dived more towards the data side of things. I've always been interested in the brain. Backstory actually is I used to want to be a neurosurgeon, not a neuroscientist when I was a kid. But then I found out I needed to go to school for that long and I wasn't really ready for it. And, computers also had my interest. So I went for computer science instead. But, eventually I came back full circle later in like 2019 and, got my first headsets. It was the Emotive. If anyone knows the Emotive Insights was the first one I had, where you needed to put some gel on the device before you used it. And I mean, I was super excited. I remember tweeting about it, trying to move a little ball or a little box upward in a virtual environment. And that was pretty cool. But there wasn't much I could do because one, I found out that I needed to pay for my data. At least that was the excuse I was telling myself, that why do I have to pay for a license to get my own data? But under the hood also, it was really that I didn't really know how to transform, my excitement into actually building the things that I wanted. I also really didn't even know what I could build with it. It was just nice, something can, pair the data that I have for my brain and do something else. Kind of looks like a signal coming in and then doing something outside. But I didn't really know much details about, working with EEG. But that changed actually, because I remember a friend of mine shared with me, because they knew about my interest, shared with me about Brain Hack in 2020. And it was like last year, December. And that's actually where I met John and Morgan and the other folks, where they were doing an EEG notebook sprint. I had the Notion 2 at the time. And they were like, oh, yeah, sure. We're doing EEG notebooks. You have a headset, want to record. And they were very helpful, really. They kind of broke things down for me. And I was able to kind of get my first experiment running that day. I mean, that kind of started up a lot of the intense work that's been happening over the past year. And, joined the NeuroTechX community, kind of asking people questions and pinging people up and down. So that's kind of what led to a lot of the things that I've been doing in the space of neuroscience itself and neurotech. So, I mean, I'll just kind of get straight into it. The first project that I actually tried doing after, the whole EEG notebook sprint during Brain Hack was this project I called Brain Dump. And what happened was, when the pandemic started, everyone, working from home, people were asking, how was your week? The first week for me was like, okay, it was good, productive. The next week I was like, kind of meh. I didn't really feel it. The other week things were going. So it kind of felt like a bit of a roller coaster. But then also it was really just my own experience and me just trying to qualify things myself. And I was like, okay, you know what, let me actually try and take it up a notch and maybe write essays. So essentially just kind of documenting how I felt about, how the day went and how things are going. But really, that only really went on for like a month. I realized that I lacked some consistency when it came to writing itself. And I was like, well, if I've been playing with EEG at this point, what can I do to possibly, I guess, parse my thoughts as text? Unknowing to me, that was a very ambitious attempt. After asking questions from people, it kind of looked like, okay, well, what you're talking about, you need invasive devices. You need something very close to, the neurons themselves to really get such kind of strong signals. But me being a stubborn person kind of went ahead to go ahead and try it myself.
You kind of had to be stubborn to be a developer, right?
Yeah, I mean, if you don't try, you never know, right? So I was like, all right, sure, I'll try it myself. I didn't really know much about even creating experiments, but I was also kind of, just joining all of these talks that happen with neurotech or anybody that's really willing to listen to me blab about it. And I remember at the time, I think it was Alex Castillo. I can't remember one of the talks we were in, where he kind of mentioned, and we're talking about like the motor cortex and, how, movement starts from there. And if, you're typing, is there any signal that's given off that could highly or largely correlate with that? And so that's what led to this project in itself. I'm going to go ahead and touch a little bit on that. Just going to show the GitHub stuff that I have going in that project as I dive a little bit into it. So this is kind of how the talk is going to be. I'll give a backstory and then walk a little bit in there. So yeah, what was I doing here? I was like, okay, sure. I want to be able to, type stuff and record brain data. Sure. And then afterwards, try and see if I can, feed that to like a classifier or something else to get things going. And so that's what I did. I set up a simple like Python take hinter thing to just collect brain data in itself. And what it did was it prompted me multiple words. And as it prompted the words, you know, whenever there's a complete match, it prompts the next word. Whenever there's a complete match, it prompts the next word. And that kind of gave me some data to pre-process it itself. And then I was kind of now doing the real thing, which is like, okay, how do I actually parse this thing? How do I actually do some analysis? And obviously, again, I didn't really have much experience, but I mean, I was willing to ask people questions and look dumb for a little while so that people could help me out. And this is where Alex Milenkovic actually did help out a lot with me. So here was just me even just seeing what the data looked like itself. And what I tried to do here was I also collected keystroke data. So that is the timestamps for when I was actually typing, you know, given words. And the next thing I kind of went into doing was trying to extract instances of the given word that match with the EEG data. So essentially, I'll kind of have a EEG epoch that kind of looks like this, where this 403 rows are just EEG data that corresponds with me typing a given word. Mm-hmm. And then kind of going away from there into getting those words and then doing some pre-processing and cleaning. This one was very interesting for me because I didn't know about all the noise that was happening there and trying to filter out the noise. You can see here, I tried out some notch filtering, and notch filtering is essentially just blanking out the frequency on those parts for anyone who is curious. And so after cleaning that up, I mean, I tried to do some Fourier Transform to kind of represent what the data looked like from different channels. And this was just essentially like the Fourier Transform, you can call it PSD really, of me typing a given word from a single channel. So after doing this, I think I kind of got carried away a little bit into trying to be a bit fancy. And at the time, I started playing a bit with GPT-3. And so what I was going to try and do was then feed the frequency FFT that I had and the, you know, output, which was like the given words, right? So the basic ML stuff of input, outputs, and, you know, if you see another input, try and parse something out there. I tried that, but I didn't really get a lot of work going over there. And this is an interesting part of this is like a big learning for me was I think I didn't need to do the most over here. Just trying out with a simple classifier with small examples would have actually done it. But this also made me realize that I needed to properly approach this in a different fashion. So in this case, after talking with people, it was like, okay, well, if you really want to do this, you need to be a bit more strategic. So in the terms of, you know, you need to create test beds, you need to try out things in different ways. So instead of just grabbing a single word every time, how about you try and grab maybe even just, you know, a single letter or even expand it to a whole phrase or change the things that you're actually parsing because the words in the context that which they're written could actually evoke some more response than I was expecting. So doing that, I was like, okay, well, looks like I have a lot of work to do. And it wasn't that I was being lazy, but I think I'd actually put in a lot of effort into getting things up to this state. And I was like, okay, you know what? I think I need a break. And so my taking a break from that was essentially what led me to the next project. So I went there and I was like, okay, so why did I actually try to start doing the brain dump in itself? I think for me, the thing that was most important was getting, instead of just my own, I guess, qualitative feedback or ideas of what things felt like, what I wanted to do instead was actually just take a step back and say, hey, you know, how am I actually, you know, approaching my day? How am I actually spending my time so that I can actually, instead of just me in my head saying, oh yeah, today was a good day or today was a bad day, or oh, I need to sit down and write a little bit about it. We already give up data every time that we move around, right? This computer that I'm on, the conversations that we're having here, everybody, I mean, there's a timestamp or an entry somewhere on somebody's database that says that you were on this conversation. Obviously not to be spooky or anything, but we give up data, but it's not really being used for us. It's used to serve as apps. And I was like, okay, what do we do when we kind of take all of these things, bring them together into one view and see what comes out of it? And that was what led to this project itself, which, you know, I've been calling Fusion for a while. I hit up one of my friends and, you know, she was down to work with me on this. And then we started going on. And what we did was we pulled up the data from Activity Watch or Spotify, GitHub, Google Calendar, Twitter, Neurosity. And essentially we went ahead and started doing basically I'll go ahead and show you the repo itself. We went ahead and then started doing analysis on that data.
Can you reconstruct the self-identity from all these sources?
like putting them together into one person's identity.
Yeah,
So
just by looking at the data.
Yeah, this is where it kind of gets a bit tricky. So far, when I was actually doing this, I think one of the most important things that for me was that this data has to kind of stay on the device, and not, be stored on somebody's database that somebody else can look into. I started trying to explore the identification of the data itself, but I haven't really made a lot of headway over there. But I think that if you look at it, I mean, this is really a walkthrough of somebody's life, right? Because there are timestamp entries that says, oh, you're listening to this song on Spotify today, or says, your heart rate was this at this time.
Exactly.
So this is very muddy waters, really, for people who don't like to be tracked or anything of those sorts.
Well, I even thought that it's only your data, but then you're saying you're collecting data from a multitude of people.
Oh, no, this is for me. This is only my data so far. This has been only my data, and my idea, whenever this has been shipped, is that it's only going to be your own data, and you only see this yourself. So in this case, your stuff, you're going to be able to pull them up, and then, the data sits on your device, and whatever, inference and stuff that's happening kind of starts from there.
As long as you're in control, everything is fine.
Yeah, exactly. You want to put the data in the hands of people. I think that's the idea for this itself, right? Instead of just being a byproduct for people's telemetry, like, how can my data actually serve me myself? So yeah, we kind of went ahead and started building a couple like data collectors from these different sources, and then went into like a little bit of data analysis itself. There was a lot of cleaning. I don't know if I want to go through all of it, but I can show you some example data outputs from like the cleaned Aura data and then cleaned Activity Watch data. For anyone who doesn't know Activity Watch, I'm just going to give them a little shout out. Activity Watch is this tool built by Eric. Eric is one of the developers on the Eeg Notebooks too. And what they do here is pretty much offline first data collection on essentially what tabs you have open on your computer. So right now that I'm using Activity Watch, there's going to be a log somewhere that says, hey, I was using Activity Watch open source time tracker on Microsoft Edge. I have a terminal stuff open here. It's going to say I had a terminal open working on Eeg Notebooks, that kind of thing. So imagine that over time, you can really see what you were doing and what was going on over there. So after cleaning up that Activity Watch data, I think the more important part that we wanted to kind of go into was looking at correlations on the data itself. And correlations in this sense, meaning that what things are kind of like are related to each other. So is my sleeping early more likely for me to actually work on neurotech stuff? So after I grouped the data set, I was going to show you a clean data set. So this is cleaned Aura Ring data. Aura does a pretty good job of giving you all of the stuff that you care about, your number of time that you slept, your activity, inactivity, and whatnot. And then from Activity Watch grouped data, you can kind of see something like this. After building the classifiers that we had for trying to understand the events that people were looking at, what you'd see is essentially things like, oh, I was working on my computer and the classification was this, or I was doing VS Code and the classification was Eeg Notebooks. And it tells you how long that was going on for. And so on the correlation side, what we started trying to do was essentially build one whole combined data set itself from this, and then trying to see what is related to the other one. Funny thing was, after doing the collection at first, the person I was building with actually fell very, very ill. And I was also kind of swamped with a lot of work stuff and changes. So this project kind of shelved a little bit. And then later on, I kind of got a bit more energy and decided to come back to it. And what was interesting when I came back to it was I decided to build like this very quick little dashboard. And the dashboard was saying, from the data that I had, what projects was I working on, or what things was I spending my time doing over time? And also like how often did that happen? So the Brain Dog project I was telling you all about was happening a lot at the beginning of the year. You can see between like February up until like March. And when I was like, okay, you know what, I'm going to shelve this. I joined a new team, so I was doing a lot of personal stuff. But something interesting, which is the Fusion project I was working on, was here, working with my collaborator up until like around this period where they kind of fell ill. You can see that there are no activities for this project at all. But something very interesting that happened is the activity that I had for Netflix increased a whole lot more because, I was rested, man. I was tired, right? I was working, I was doing other stuff, and I was like, yeah, I'm going to take time off for myself and do the things that I wanted to do instead.
Your Zoom track is also hefty.
Yeah, I mean, yeah, there's
Zoom fatigue.
Oh yeah, I mean, this is actually like this here is supposed to be like a container for when I remote desktop into work stuff, and then after a while I stopped using my personal machine to remote desktop in. But what these look like were just for me to kind of just see what the data looked like itself before I went into doing correlations into that data. And you can see other stuff here like text using brain interfaces because I was looking at some stuff with brain dump and whatnot. But what this kind of provided me was trying to see if my interests and the things that I was doing were actually aligned. And this kind of served as the basis for the other things that I plan to add to this, where it comes to now looking at, okay, when we had data from like our EEG devices, what do we get from there? And so this is still in development right now. This isn't anywhere near complete, but I thought it was fun to share on this right here. And this is what the Fusion project was about. So the real part that I'm going to delve deeper into over the next couple weeks is really around getting correlations from these kinds of data that is claimed together, and even doing things like conditional probability, where we say, okay, which of these things actually contribute to each other? Like, does listening to some certain music on Spotify, beyond just the correlation, because obviously people always say correlation is in causation, right? But using different data science techniques and different tools to actually try and do conditional probability around the context of the things themselves and seeing what kind of aligns. So yeah, this was
another thing on that, Ori.
Yeah.
Sorry to jump in, but like you have time series.
Yeah, exactly.
Right. So there's a lot of neat stuff you can do with time series, particularly in the area of causal inference. And you have you have a lot of periodicity because you have days and weeks, right? So that kind of messes a little bit with some of the things that you would like to use, like something starts and then something follows it, right? That's like how you kind of get causality out of time series. But I still think it's a very rich place to look for that. I don't know, like I turn on this music and then I do this, or I have a kind of really productive day and then this follows, right?
Yeah, exactly.
And that kind of sequences.
Yep, and that's why like. And that's why, like, when I was trying to pick out the data sources, I wanted to kind of touch on different areas. So that's why you see things like Twitter, for example. And Twitter was kind of looking at, the things I was liking, which is kind of stuff I'm consuming with the signal that I actually, interacted with it, or tweets. And that's kind of looking at things that you create and stuff that you put out there. So that it's not just kind of scoped to, your work and the things that you're doing, but, also accounting for other areas. And with Neurosity itself, this is actually going to touch on the next point, Neurosity kind of has pretty good predictions on focus and calm. For those who don't know about Neurosity, the makers of the headsets I'm wearing right now, pretty cool guys, wonderful people. Buy their headset if you want to. They didn't pay me for this ad.
I like to, sorry to interrupt, but
Yeah.
I like to interject as well. So the Neurosity pipeline is machine learning pipeline, if I understand well. However, before John and you were mentioning causal inference, is that where you use your conditional probability to understand correlations of events that are succeeding in a sequence one after the other?
Yeah, I think that's where the correlations come in first, right? The correlations are even looking like, okay, I have this breadth of data, different context, right? And then I kind of want, what I have to do now is kind of bring them into one combined data set and then just see basic Pearson's or Spearman correlation on these things. And then from there, I kind of see what events may have some correlation. And then now start trying to do the things about conditional probability or picking like over a time series and saying, for this group of events, what other things are likely to happen.
That's interesting. And we do already have a couple of questions from the audience. Are you able to take questions right now?
Yeah, sure. Let's go for it.
Yeah, I have just a question from Alfredo. Hi, Alfredo. And Alfredo is asking, can this environment log more than one person to be able to study and model social behavior systems?
Well, it's kind of tough, right? I think in reality, if you wanted to, it will. But this is where it kind of goes into the thing of data privacy and consent. Like this stuff is really private data. Like the meetings that you're doing on your calendar, right, is really like as private as it gets. Your brain activity, we all know, is super private. The things that you're doing on your computer is super private too. So I haven't really gone deeper into exploring how to do social sharing for this kind of thing. Because the first thing I wanted to kind of look at was, okay, for a given person, what can we actually provide to say, one, after providing a better picture, how to actually help living with themselves. But that's a pretty good idea. I think it's something that will probably evolve down the line, but it will be something that has to be initiated by a user that says, okay, yes, I consent to sharing what this looks like, because the model so far is that, fetches the data or go through the data collection and keep that on the device. Because there's no way, I haven't explored yet, how to keep this on a server somewhere, still de-identify it and not do any, thing
Sure.
that, I don't want to be a
Very
Facebook.
interesting. It's not, there is Facebook on one side and there is private data on one side, like your own data, but it's something in between, like Alfredo is actually pointing out in the chat here, which is family data. So if you're a big family and you collect data at home on your laptops, then you could also eventually think about correlations of your, different Spotify, Neurosity, Github, what you have, their systems and causal correlations, and genetics, because you're part of the same family, right, at some point. And that's an interesting point. But anyway, so for the audience, Ora and John, could you briefly tell what you intend by causal inference? Because that's interesting to make the distinction between, Pearson and Spearman correlation and causal inference in a probabilistic way, in brief.
Sure. Jin, do you want to go, or?
Yeah, I can have a go, and you can tell me like how you think of this differently or more expansively. So, okay, kind of statistics general terms, right? What are the things we look for? We look for relationships between things, variables, and if you forget the existence of time, then that, broadly speaking, is what we think of as correlations, right? Things are related. When this is high, this is high. When it's low, when this is low, this is low, right?
Yep.
The point about causal inference is that you have you can use the broader, basically mathematical architecture of statistics to learn about something that's a little bit more how you think things actually operate in the world, where you have, right, like, to take just a kind of off the top of my head, right, like I have if I have a billiard ball, right, and I throw it another billiard ball on a table, pool ball, then that's a causal event, right? This thing affects this thing. So that relationship, right, this thing having an influence on this thing, that's the kind of thing you're getting at with causal inference. Like you want to be able to kind of formalize that relationship, and then have statistical techniques for like finding that relationship when it's present in some measurements that you have. And when I was talking about time series, there are a few branches of causal inference in terms of the statistics, but one of them uses this idea of temporal precedence, right? Where like you have an event, and then if another event follows shortly afterwards, then you have like a basis for assuming, inferring, etc., that event 1 led to event 2 in a causal sequence, right? So like particularly when you have time series data, then like you can aim to learn some of those things about how one thing in your life or one pool ball on the table affects another pool ball on the table, because time flows in one direction. Makes a lot of sense
to have at least exclusion of time flowing in a different direction. But I know for sure that one of the way of doing causal inference is using conditional probabilities, and the other is using counterfactuals, which is decision trees about what decisions you should not take to have a certain outcome. But I believe your system doesn't go into that, right?
No, not yet. I mean, this is still like largely in development. I mean, I don't have a problem sharing because I feel like, ideas are free, really, right? But this is rightly so in the middle of what I'm doing right now. Even today, I was trying to do some more correlations on this data itself, and explore different ways to actually provide these insights to people. And so the interface will probably be a lot cleaner than this. I feel like this is fine for someone who actually knows how to read a Gantt chart. But in reality, for me as a user or as a consumer, all I really want to see is, hey, on the days you sleep more, you're more likely to do X, or you're more likely to do Y, when you pair this with listening to music and X, Y, and Z. Yeah.
Fantastic. And Alfredo, ask what is the time scale of a typical analysis that you show in your graphs there?
Oh yeah, this right here is on this analysis here. Each dot or each marker that you see here is a day, and these here actually combine to form the total time spent in terms of hours over the whole period of time. So in this case, this is kind of looking at the frequency of these events as they are happening at a glance, right? Okay, this is at a glance the times that I did X and did Y, and on this other hand is looking at how this sums up together. But this right here is going to change. Like this is a very, very loose development visualization, but on top of that is now going on to build something a lot easier to explain and a lot easier to understand when people take a look at things at a glance. Yeah.
Are you able to take another question before, not to interrupt your flow too much?
Oh yeah, sure, go for it.
So Michael Feldman asks, what's the link for Fusion Journal GitHub?
Oh yeah, I mean, it's still a private project on GitHub. I think once it's at the proper state where I can share it, I will. But at the moment right now, it's still like private and in development. But we are kind of exploring whether to do open source or not. I'm leaning more towards open source because it's a lot easier to get people actually contributing and building on top of the knowledge. But yeah.
Yes, that's the spirit. Thanks for that.
Yeah, you're welcome. So next thing I have in here is the logger. And what this logger is in relation to the fusion I was showing you before, where I was saying, we're getting data from different sources and bringing them together. What this logger is that, so for anyone who's tried recording EEG data before, you always need to have a computer with you or another device really that is receiving the signals. The good thing about Neurosity is they have a JavaScript SDK, right? And you can actually kind of plug and play into that SDK itself. And so what I was trying to do with this neurologger is essentially use their SDK without requiring a computer to go straight ahead and then, log your focus metrics, your calm metrics over time once you turn on the device. And this is really like basic JavaScript stuff, right? Listen and subscribe to these events and record the data for a certain while. Collect the, alpha, gamma, delta, all of the stuff and store it somewhere. And this way, basically the reason why I did this was like, for me, since I started recording experiments, one of the things I realized was that, you need to do some baseline stuff before you actually do the real thing that you want to do. In reality, like a good example is when I want to play the piano. So since I started playing the piano again, I've been like, okay, I want to see what my brain activity looks like. But then, I mean, it's also the thing of like, the decision to play the piano is already like a high effort decision. And then now trying to add the fact of, oh, I need to now go grab my laptop and then I need to run this thing and then make sure that I do like a 5-minute baseline before I then start recording the actual time to play the piano. It's like so cumbersome that eventually I was like, okay, you know what? There should be a way where I should just turn on this device and just, do whatever I want to do for a while and reducing the amount of friction required to kind of get started. And that's what the logger was, or what the logger is. So this essentially just logs straight from Neurosity, like, your calm and your awareness data, your focus data itself, also logs the power by band, and then signal quality to help you kind of understand whether or not to trust the data that you have going on. And this, connects to an Azure function and just goes ahead and, uploads this to like a source where I can always query in the future and use even reproducibly for other experiments, right? So now the EEG data that I have, and because I've also used so Neurosity actually has a pretty cool way of like, looking at recordings that you've done over time. So at first I used to have all of these recordings here that, I have to manually download and then go feed into my stuff. But now with the logger itself, I no longer need to, manually go download this and get it started. What I just need to do is kind of just have it on. And then whenever I need to do analysis, going back there. But one of the interesting things around this is really because I want to be able to kind of see how my brain activity evolves over time and over multiple days is why I want this, where I can just have it on and then just have it recording. The next thing I want to do with this is really kind of triggering message prompts to myself to kind of understand what's been going on. So these kind of form like tags for whatever data was recorded. So imagine like a simple Twilio API to ping you and ask, oh, what were you doing in the last 30 minutes? And I'm like, oh yeah, just playing games and chatting with friends.
So to understand better, so your Neurosity device, which is the crown, I believe.
Yes, the crown.
this is already a sort of a microcomputer embedded in the headset that does the timestamping for you to log events, as long as the battery goes, events during your daily routine, including programming, playing piano, and so on. And that has added value on as a baseline, as a boilerplate application, on top of which you have Neurologger that extracts that data and then streamlines that into sensible data that you can consult.
Yeah, exactly. And in reality, like if you kind of see where these things are leading, imagine focus and calm being added into Fusion straight away as the things that you now look and try even do more correlation on that. And towards there, it's really like, I don't really know how far I want to explore with EEG. And so I have been wanting to kind of have this data that I've been recording kind of in a more structured form that I can always go back and look at, instead of a bunch of 20, 300 and so CSV files that I can't really pair to anything. Like it's one of the most cumbersome parts for me when it comes to doing this stuff. So that's why I started working on building this itself.
But that's important, because actually it's related to one of the questions from the audience, if you can take one.
Sure.
Alfredo again, he asks, how in fact do you synchronize all the clocks from incoming streams from everything that you have? Do you have one master timeline, master clock?
I mean, for me, UTC never goes wrong, first of all. But then again, the Neurosity provides you the timestamp in milliseconds, right? So let me see if I can find one of the examples I was looking at right here. So you'd see something like this has a Unix timestamp. So it's really just Unix timestamp across, and then using those to do the correlation themselves. Obviously, some will be in fine grains of milliseconds, some will just be in microseconds as far as they go. But so far, so good. Just using the Unix timestamp, and obviously in other cases, just always converting them to UTC at first. So for things like Spotify and whatnot, get them in the UTC version, not my local, PST or whatever. And so that kind of handles that.
UTC for the layman is a protocol that is thought, it's related to your laptop clock.
So this is pretty much the middle of everything. Everybody can just always reference UTC regardless of, wherever you are at, if it's even -8 or +5 or whatnot.
Here you go. And Alfredo, that's your master clock. Hopefully you're satisfied. Yeah. Please go on.
Awesome. Yeah. So that kind of touches on stuff. This one will be definitely open source. So I would share a link maybe to the NeuroTech Slack whenever I finally push all of these things out here. But the final thing I was going to talk on was Eeg Notebooks. This thing here, this is talking about, longitudinal self-studies and keeping things going over time for multiple periods. And it's not really that futuristic, it's pretty much here, but Eeg Notebooks is here for you now on the GitHub repo, ready to run.
I like the guy with the NeuroTechX, headband.
Oh yeah, I stole this from John, by the way. John, do you remember this?
This is one of the greatest accomplishments of the last few years for me. This image.
They have the logo. They will die for NeuroTechX. So.
Yeah,
it is a famous piece of art.
Yeah, it's really nice. I think the first time I saw this, first at the Brain Hack actually when you gave the talk, and I was like, pretty cool. It's nice to see all of this little headsets jumped on top of them.
The woman has an OpenBCI product on top of the head.
Yep. This is fully neurotech and
Ultra Cortex. It's amazing that at that time they already have availability of Ultra Cortex.
Back then, this painting, I think I saw this in the Louvre a few months before I did it. It's called Liberty Leading the People, right? It's a kind of it's about the French Revolution. So the people lying on the ground, they're the people who got outed. And as you can see, if you take a look at this representation, we have high density, expensive, clunky, large, old school EEG systems and MEG there on the bottom right as well, lying in the mess. And the new guys have all got the mobile devices.
Yeah. I think we can easily reverse the picture, but I see an MEG there that It's kind of a miniaturized MEG on the right, bottom right.
That's right. Yeah. I mean, that's probably not like accurate with old school cryo MEGs. Actually, they're on the way out as well,
for sure,
for other reasons.
Yeah, but I mean, now you can use cheaper headsets.
Mouse MEG.
Yeah, now you can use cheaper headsets like, you know, the Muse or OpenBCI, Neurosity Crown. I think the best parts of how, you know, devices have evolved for me is that like I was saying, I mean, I think I even have this right here. This is when I first got the Emotive Insights. I remember that I have to actually put gel on this stuff, right? And now you can see my hair is a lot different from other folks. And then imagine the process of, imagine I want to start up today and play the piano. I now have to sit down and say, okay, where's my gel? Let me touch it up and put this right here and do this. I mean, I never did it. That's why I didn't really do much work on this stuff, because the amount of effort required was a little too much for me to actually do. So,
you know, Ore, there are amazing nets. There are high density nets that are easy to apply with no gel.
How much are they?
You know, they are very available. It's 1 month. It's a 1 month ago release from a company I know very well, and ANT Neuro. and
isn't that your company?
They work, yes.
They're good. I've seen them. They're actually just, you know, I'm not paid by ANT Neuro at all, but honestly, the ANT Neuro caps are like the best EEG caps I've ever seen.
Really?
They are the slickest. Like, it's like wires integrated into the fabric. Like, you wouldn't know there are any wires. Anyway, sorry.
Yeah, can they go through my hair though? That's the question.
That's a very good question. Actually, the caps, it's tricky, but for dreads, the nets are fantastic because they are elastic.
Yeah, the nets. Yeah.
All right.
They are sponges. They go in between.
If you send me a link, I'll definitely check it out. Check it out and see what that looks like. But yeah, on EEG notebooks itself, I mean, we've kind of heard a lot about EEG all day, and you've seen this for a while. Is that you can run cognitive neuroscience experiments at home. This was I keep saying that this was very formative for me in terms of like my exploration of EEG and even brain interfaces at all. Because I mean, I decided to join, and in a couple hours, I'm able to do the simple N170 experiments to see the houses and faces of people. I think was the N170 itself. And it was funny when I used that one at the time, I didn't really have good signal quality. Signal quality has always been one of my biggest problems, by the way. Obviously, you can tell why. But so far, it's actually kind of gotten better. This Crown device actually does a bit of a better job. And so ourselves, the folks at EEG Notebooks, together with CamH and NeuroTechX, OpenBCI, have been working on the NeuroTech challenge. And what the challenge is simply trying to collect data in the wild, if you want to dumb it down to the simplest form. And you're contributing to, science, which is good, of course. And you're essentially, the thing is, we've had this repo, right? You can record with anything. You can record with Crown, OpenBCI, Muse, LSL, whatever, and you can get these things going. But what we don't really have is a good data set to look at this from various people and see what they look like. And just having that alone serves as a good basis for people even trying to build on top of this data. So this is the reason why I actually added this slide. It's not like I'm begging you for your data, but I'm kind of begging you for your data if you want to join in. So the NeuroTech challenge is gonna kick off, I believe, very soon, probably in December. John, keep me honest in there. But some of the things that we've been doing so far is actually adding some updates to EEG notebooks. I've been talking about signal quality being one of the bigger challenges that I faced. And one of the things that we added was signal quality checks into EEG notebooks itself, literally to the channel and device level. So you can kind of see over here, before you start an experiment, one of the things that we're going to do is to get you to run a signal quality check. And then when you run that signal quality check, it kind of tells you, how good or how bad this is, so that you kind of know what to expect. When I was running this last year, December, there was no signal quality checks for me. And I was just kind of curious, like, okay, is there something wrong with my brain, or is there something wrong with my data? And then after, looking through and asking a lot of questions, we found out it was signal quality. So these are probably good things where it helps people kind of identify that, oh yeah, you need to actually have good signal quality, or you actually need to know what to expect before these things happen. So yeah, this is on my head right now, and it's checking for like bad channels. It looks like things are pretty good, and I'm all set to go ahead and record. And now I can trust that, whatever is coming out of this is going to be valuable recordings for us. So yeah, try out EEG Notebooks. Shameless plug right here. Look out for the NTCS challenge when it comes out. There is the opportunity for a raffle draw and a prize. I'm not going to spill the number for anyone, but I think is, John, how much is it again on the raffle?
Those numbers are still being confirmed, but there will be some decent prizes available for people who participate.
Awesome. Yeah, so I mean, you're contributing to science, you're contributing to open source. The money is like a cherry on the cake, of course. So that is EEG Notebooks. And then finally, the other thing I was going to talk about really is, I've touched on some of all of the projects that I've been doing. And now I just kind of want to touch on the challenges, and you'll probably see them across all of the work that I've been doing before. One of the things that you see for starters is, for me, the biggest challenge I've had has been, one, just understanding of the space, right? I am a software engineer by background. I can write code, I can do all of this stuff. But you tell me that, oh, you need to notch this signal at this frequency and then do a band pass and a high pass. When I first started, all of this stuff went all over my head. I had no idea what this meant. Alex really sat down and explained a bunch of this stuff to me. So I think there's a lot of opportunity for really making this a bit simpler for people, or easier to get started. And that's where, some of these efforts that we're trying to do with, EEG Notebooks, getting people trying them out to actually see what happens there, more documentation and stuff. And the other thing really is a conspicuous form factor. I remember when I was in Toronto with John, if you can remember, when we went out for dinner, and I was kind of unsure whether to pull out my headset or not. So we're there, and I was like, okay, I'd like to see what this looks like.
You got a good response.
Yeah. I mean, it was fun because somebody showed up and was like, oh yeah, this is a nice headset, and hopefully they go look out for like, neurotech stuff and start doing stuff around there. But it's a bit harder, so I feel like people aren't really ready unless you're like super excited about it. No one's going to sit down wearing a big helmet on their head. But mine kind of looks cool, though. I mean, depending on who you ask, right? And the other part really...
The guy came up, you had it on your head for about half an hour, and the guy came over and he was super enthusiastic. He was like, hey, what is this? Tell me about it. This is amazing.
Yeah. I mean, the thing is,
awesome
I wasn't
going
to bring it out, though. But John is like, I mean, you got to do you, man, if you want to do it. So that's why, I mean, for other people, maybe they may not have a voice of an angel in their ear saying, pull it out. But beyond that, it's really that no one really wants to wear a big ass headset on their head, especially at the stage where we're only kind of getting to that point where people are starting to derive value from these headsets outside of just, oh, it's cool to see EEG and see what it is. We're kind of now getting to that point where you have focus and calm and things to help you do stuff. So hopefully these form factors become a bit easier. But one of the other things, or the biggest challenges I faced, was really around designing test beds and reproducible experiments. As you can see from the initial brain dump project I mentioned, I started super excited, maybe even super ambitious, and then kind of get to that point of understanding that, oh, if I really want to do this, I need to have a proper collection pipeline that can do the data collection for me. And also look at the different variables of how I can do a test, right? Am I doing one letter? Am I doing one word? Am I doing phrases? What words am I using? Are they related to each other? These are things that I only considered when I started doing this type of stuff. And the final part is really finishing what I start. Sometimes I kind of get tired on these things and then I kind of jump onto another project. But the good part for me is that they're all related, so I can talk about them in one story, and they don't sound like a half-baked project here and there. And the road ahead for me really is, one, the fusion that I mentioned, or that project I talked about. My collaborator and I are working to kind of get an alpha release going soon. So hopefully you guys are willing to try that out. Part of the other things is trying to look at like mental workload estimation. I've seen some papers around this. But you can imagine that now that I have the logger with me and I can start putting labels, I can start getting to a point where I can, explore how this looks like when I, compare EEG data from before and the labels to them moving forward. And then the final part is like, stuff always comes up as we talk with people, ideas keep on forming and building up on top of each other. The knowledge compounds. And so who knows what's going to happen ahead. And finally, what do I have next for you guys? I think the next slide here is just some fun stuff on podcasts that I like. Brain Inspired, I really like listening to this one because it kind of goes deep, but then you can still kind of understand on the surface level what's going on. The other one is Models of the Mind.
It's the best.
Yeah,
Brain Inspired.
Models of the Mind is
Really
this
good.
really cool book by, let me see if I have it here. It's by Grace Lindsay. Yeah, this is the book, Models of the Mind.
Oh,
Yeah, I love
book.
this book so much so because it's like one of the easiest. It's like it's the neuroscience class I didn't go for, pretty much, or the neuroscience degree I didn't get. So it breaks things down all the way from the start of, when scientists were trying to, detect spikes and putting electricity through the legs of frogs, and going down towards, how we make memories and how field attractor networks. And so it's very, very accessible and very easy to get into that. So worth checking out. And this stuff is just future things that I'm excited about, brain connectivity and combining modalities. And then finally, I just want to say thank you to all the people that have, answered my questions, listened to me, provided, positive and actually also hard feedback, because it's important to kind of guard yourself and surround yourself with people that can tell you the truth. Not just people that are just going to be like, oh yeah, it's cool, go try it out, but not kind of let you know what's going on ahead. So Alex Milankovic, thank you so much if you're listening right here. John, thank you. Morgan, I remember the first time at BrainHack, you were super helpful, helped me debug stuff. Thank you so much. Alex, Castillo, and AJ, they know how many times we've been working together, me asking them questions back and forth. They really did help. And, any other person who's answered my questions or shared resources with me or even listened to me rant, thank you so much. And yeah, finally, I think I'm just going to end with this little quote right here. When I talked about, having failed projects and not finishing stuff, I think most importantly is just getting started. I think once you get started, things happen, and always like the knowledge compounds. I think for me, it builds on top of each other, right? The evolution of the projects that I've tried to explore kind of started from, me trying to do brain dump and then going on top of that. I think the best part was when I was in Toronto, and I was like, I'm thinking of an idea for a tattoo. What do I get? And then I, sat down, recorded my brain activity, listening to jazz music, did some analysis in a couple hours, and then I ended up with this little nice tattoo here of that. And so it's just like me going from not even knowing how to analyze EEG to be able to get to a sweet spot where I can essentially record and then pull something out. It's pretty fun. And this is a great space. So if you have any questions, don't hesitate to reach out to myself or any of the other cool people I mentioned before. They're very welcoming and always happy to help. So thank you all for listening.
That's amazing. Thanks, Soray, for your contribution. I really love your presentation. And also, there has been a lot of questions for you. And I know that when you were in Toronto, you were going for jazz clubs, and hopefully you found one that I sent you a link of, which is the Rex.
Oh yes, I love the Rex, man. The Rex was so amazing. I spent like the whole, something funny. If you actually want to see, I could find. I don't know if I can find it here, but I spent the night at Rex that day, having fun and whatnot. And then eventually, I got back home and I was like, okay, let me record some of like my brain activity and see what that looks like using some of the fun stuff that Alex had shared with me. And then I could actually do some analysis and I could see like my foof from that. And I could actually see like this channels weren't very good, but these are very good channels here. I could see some good alpha peaks around here. And this was some pretty fun stuff. I'm not going to tell you what else I consumed at the time that contributed to this, but that was some.
I guess the Rex for everyone is a pub and a music pub, right?
Yeah, I like the place. It's pretty fun.
So it's amazing. Yeah, it's one of my favorite jazz clubs in Toronto. But I also have.
Can I jump in on with comment?
For sure.
I'm going to jump in on a comment right now. So like there are already like loads of cool stuff. I mean, you know, you've really jumped into a bunch of cool projects, not just the ones that I'm involved in as well. I think the most interesting and potentially impactful thing of everything you talked about here is this interesting problem around the logger, basically, because I'm sure you get it. Perhaps not everyone gets it. It's kind of boring in a way, but we want to. Well, put it this way: like with Eeg Notebooks, you know, you sit down and you look at pictures, they flash on the screen, or you hear sounds, right? You're looking at your screen. I mean, we say like cognitive neuroscience in the wild, it says, but it's not like you going about your day. So the most interesting thing that you said, which I think you should really kind of think about developing, is this idea of a kind of retrospective, like a post hoc labeling, because like you said, like you often don't want to be sitting down saying, I am going to do this for the next 5 minutes, for the next 10 minutes. This is what my event, my brain state will be, right? Like that's from an experimental point of view. Yes, that's exactly what we want you to do. But from a, you know, good, just living your life and kind of the things that you're particularly interested in terms of, you know, mapping your brain and cognitive function, you don't want to be doing that by and large. So that kind of post hoc, you know, diary keeping plus all of the automated stuff you can pull in from the activity watch and these other, you know, wearables that are like doing their thing automated, but like getting these labels down, this sounds like this is such an important thing to get right. And I think I like the idea of like triggering a text and having some way of, you know, easily getting that information down. Another thing that came to mind is something a bit more like, you know, your status on social media, right? Like, or something on your phone where you have like 5 options and you kind of just turn it on and say like option 1, like option 2 or something, and say like that's what's going on at the moment. But it doesn't involve like thinking too hard about it. It's basically instantaneous.
I think the threshold has to be like, you know, it has to be something that is simple enough for you to do, but also capture enough information in there. And I mean, if you leave it as a free form text, well, it's like, okay, what do I even write? And it's not even structured enough for you to build on top of afterwards. So those options there, and then maybe an option for even going a bit deeper, definitely is around the area that I'm exploring. So yeah, looking forward to, you know, finishing the stuff at least.
And I like the idea as well.
Keep us
another thing as well, which I think you mentioned, but is a cool idea. Cool idea is like triggering, like having messages that they tell you to do X kind of spontaneously, like instructions, right? So if you could set up a system where you basically have maybe randomly or structured timings saying do sit still, or sit still, turn on your music for 5 minutes now, like at 9 a.m. and 12 p.m. and 2 p.m. or something, right? And those messages come in and you respond to them, but you don't need to think about it too much. The thinking is kind of the thing that's gone into like designing when those messages come in, and then you have all the other stuff set up where you don't need to turn stuff on. You just respond to this instruction, get on with it, and then get on with everything else. That would really, I think, smooth things along.
Definitely. Thank you. I'm gonna definitely steal that idea. I'll credit you, of course, and I'll try to get it going.
I thought you said it. So.
No, you know, the ideas build on top of each other. They compound. So yeah.
Thank you, guys. It shows that you're working together. And I want to thank you again, Ore, to be bringing us this amazing contribution for Eeg Notebooks and all the nice projects. I share the GitHub repository link in the text here on the right for the audience. And then we glossed over that, but Ore also works at Microsoft, and he has a blog, and he is originally from Nigeria. So we hope that we will open a chapter of NeuroTechX in Nigeria soon.
Yeah, I mean, that'd be amazing. I know a bunch of people have reached out to me. I mean, I have times where people book time for us to chat about anything. And I noticed that over like recent times, the conversations have kind of steered towards, oh, what's this neurotech stuff that you've been doing? What does that look like? And I think just democratizing, access and understanding for people builds on top of that, right? Because the first part is understanding, and then after understanding, your ideas start becoming a bit more formed and structured into actual things and not just like darts in the air. So I'm looking forward to that happening. I'm looking forward to even having, cheaper devices for people. I know we're at that point where technology is getting cheaper, and it takes time. But over time, I'm looking forward to people, joining in. And first, even the NeuroTechX chapter in Nigeria would be one of the really, really cool stuff that we can do. So, yeah.
Thank you so much, Jorge, also for being an advocate for this.
You're welcome. You're welcome. Thank you all so much for having me too. I really had fun sharing. I was kind of nervous at first, but it seems like it turned out pretty fine. So thank you.
Yeah, it was fun. Thank you for your contribution.
Awesome,
I'd like to go to the next guest tonight, and I'm gonna have Eden on instead of you, if you're fine.
Yep.
And but stick around for questions, and until the end, we are here until 10:30ish, and we will have hopefully more questions. Thanks,
Awesome.
Jorge, again.
Thank you.
And I'd like to invite Eden now. If you're around, let me see if I can invite you on screen. There. Let's invite Eden. Looking forward to this presentation too, John.
Yeah. Eden's got a lot of interesting things. Hey, Eden, how's it going?
Got my ginger beer.
Cheers. I have my cider here.
All right.
Can you hear me all right?
Yeah, very well. You have a very nice microphone.
Thank you.
Yeah, please take it away. I can make a brief introduction. Eden is research consultant, full stack neurotechnology developer in medical science and entrepreneur. And he's calling us from Edmonton, and he's executive director of NeurAlbertaTech, and also co-founder and CEO of Rembrandt. Please take it away from here.
Alrighty. I'm going to start a screen share for my presentation, and then I'll have some demos throughout. You can see this?
I can see.
Yep.
Very well.
All right. Hello, everyone. First off, thanks, Chris, for the invite. I've really enjoyed attending the podcast over the past few months. And yeah, I don't like talking about myself, so I'm going to start off my presentation with a few minutes talking about the organization that underlies many of the projects I'll be chatting about today, so as to tie everything together nicely. So yeah, this presentation on my end is brought to you by NeurAlbertaTech, and I'll post the website in the chat later. But yeah, it's exactly as it sounds. We combined neuroscience, Alberta, and technology. We're operating in the province of Alberta in Canada, and the nonprofit's tagline is Alberta's premier neurotechnology innovator network. So a little bit of a mouthful, but as you expect, we're focused on fostering local innovation in the neurotech space. And so the core of the group is a growing gallery of internal projects, which individually aren't intended to be earth-shattering, groundbreaking in and of themselves, but more so provide a roadmap and training grounds for local innovators. And we're trying to overturn, or at least challenge the view of the innovation in the innovation space, that it's a zero-sum landscape. So trying to shift towards open source and collaborative and open access projects that transverse academia and industry. And yeah, so we do that primarily through project teams. And this is logos for a couple projects.
I'd like to mention that NeurAlbertaTech started as a NeuroTechX group. It was it was implicit, but it was there.
Yeah. So we started in early February 2019, and we kind of just blossomed from there. And this slide kind of denotes the core being project teams we formed around the student competition, and that maintains still our core to this day. But we followed up on the internal project teams with practical and targeted neurotech focus workshops. So we do basic Python all the way to looking at the neurological underpinnings of brain diseases.
Nice.
And trying to pull out tangible intuition throughout the workshops. And then we also host speaker and networking events, including Canada's first official BCI hackathon that we recently put on. And yeah, I'm always scared about not defining my terms. So before I get into projects, I'll just take a couple minutes to go over the basics, the basic underlying methodologies and principles, so as to not scare off anyone who's brand new to the space.
Thank you for doing that.
Yeah.
What's the Brinkley Interface?
Yeah, this is a broad overview that defines the shared characteristics of all brain-computer interfaces. And yeah, you have an initial acquisition phase followed by some classification of an underlying brain state, and finally some output that feeds back to the user in a meaningful way. So a little bit abstract, but there's broad strokes of a BCI pipeline. And then all the projects I'm talking about today are rooted in EEG as the neuroimaging method. Other projects take in other biosignals. But EEG, in short, it involves the measurement of very tiny electrical potentials. So on to projects. I'm going to start with the three internal NeurAlbertaTech projects going on, starting with Koala Academy. So it's not currently available outside of beta, but with Koala Academy, we're working towards providing open access, web browser-based, BCI-optimized support for Mandarin learners. And so this is kind of the start of a shift towards caring a little more in the experimentation realm of the user's experience. So unlike most human EEG research projects I've been a part of, we have an eye towards trying to make it a task that's actually enjoyable. And this project is currently part of a validation study in the Faculty of Rehab Medicine in the Department of Communication Sciences and Disorders at the U of A. And yeah, I'll go more into this. So this is just a splattering of some of the tools we're using in the platform. We use serverless web hosting from Firebase, among other Firebase tools. And we do our ML model generation on the Google Cloud platform. And then the site itself is heavily JavaScript using the React library. And so next, I'll go into the research aspects of the project. I have the oddball here in red because that's where we currently are. We've been collecting data for a few months, too many. but really we're just confronting and overcoming various technical hurdles, but luckily with some good success. And yeah, our next task I'll get into more.
May I ask a question on what is the meaning of oddball in this collection of data?
Yeah, so I'll actually have a demo of the specifics, but of these two parts of the study, kind of just overlaying it on top of the BCI pipeline. The oddball is specific to validating acquisition, whereas the language learning task is looking at classifying brain state and the validity of doing so.
Thank you. It's like an oddball task in psychology.
Yeah, just the typical cog-neuro task. Yeah, and I'll actually walk through what that looks like on the site itself. So yeah, here is the montage we'll be using for both studies. So this is using a OpenBCI site on DAISY, which is 16 channels, but we'll be reinitializing 2 channels as EOG shown here. And this is our standard way of acquisitioning EEG data that we're comparing to the Qual Academy platform. And the platform we're hoping to have just work through Google Chrome. So after validation, we're hoping to do away with needing an Arduino, a photodiode, and then accessing the stream with Python and BrainFlow, and yeah, doing it all within the platform itself.
I'll drop a link to BrainFlow and a couple of other components here.
All right, and then yeah, terminal time. Yes, I actually got it started beforehand. Hopefully you can see my studio code.
Yes, I do.
Yeah, so we're just going to run through the oddball itself. And so this is just a local web server that I'm running through the terminal. And yeah, so we have right now, we can connect to the site on DAISY OpenBCI or have a mock channel. These look a little gross, but they work. So I'm right now at home have a site on DAISY with the Think Pulse electrodes. And then when we're doing research, data collection, you can reinitialize those last 2 channels for EOG. And so, of course, you need the resultant hardware change. And then another debugging setting. Yeah, it's pretty standard, like web Bluetooth. So not sure how exciting that is. So I'll just use mock for now. Yeah, and then this is a streamlined way in which we can save data to the cloud and then refer to it afterwards. And then these variables are currently set in the back end, just deciding the number of tutorial trials and then trials per block and blocks. Yeah, and description. So pretty standard. Yeah, we ensure people are actually doing the task correctly.
Do you take questions?
Yeah, I do.
So while you're presenting the stimuli, I believe you have a flickering bottom right square there.
Correct.
How reliable are the timing in the Chrome browser? the timestamps of these events? How reliable are they?
Reasonably so. So it would depend on quite a few factors. The biggest threshold being the frame rate, the max frame rate of the monitor itself. So right now I'm piloting on a 144 hertz, and yeah, that's kind of the main one. And then you can constrain refresh times through React.
Pretty fast though, unless
Yep.
you're using, you know, a bazillion open tabs on your Chrome, right?
Yeah. Well, I have that bad habit, so I've got it working pretty well with like 100 tabs open. So
Oh wow, yeah, that's
probably
impressive.
not advised. Wouldn't do that in a research setting, but for debugging.
Gotcha.
Yeah. So then from here.
And the meaning of having the square on the right there is to keep track of the with a photodiode of your experiment.
Correct. Yeah. Yeah. So here, then the data is uploaded to Firestore and Clouds. Firestore, which is a service from Firebase.
Thank you.
And then static storage. And so you can download it manually, or you can write a script to iteratively grab them from the cloud
Understood.
directly.
Yeah, I use Chrome very often. Actually, I use Chrome to host the Crowdcast, so it works.
Mm-hmm. Yeah. Yeah, so that's that one. And yeah, so we're still currently on the oddball, the hardware validation. But as many of you are probably aware, setbacks in research aren't always a bad thing. So with Qual Academy, the development of our learning task architecture has continued on in parallel. So now this is getting into that language learning task portion of the second study. And so the program as a whole is predicated on the subsequent memory effect, or the phenomena of being able to differentiate brain signatures with behavioral outcomes for memory encoding events. So as to say, your brain looks like this immediately after presentation of an association, if you're going to remember it at a later time point. Whereas in contrast, your brain looks like this when you are not likely to remember it. So yeah, the first portion being we get a baseline, we get their brain data at time point 1 in the study phase. So we have a cross-language word association pair. And then we pair that with the testing outcomes. Yeah, and then that labeled brain data would then be passed. And we would generate a model. And so more abstractly, you can think of this model as predicting whether someone is learning or whether they will remember something at a later time point based on whether or not they're like looking at their teacher, but instead of looking at their eyes, we're just looking at a very particular time-locked brain signature. Then based entirely off of the brain data, we can then classify their propensity to remember associations, and then change the stimulus throughout the session such that we focus on learning material we predict they remember and avoiding material that we predict they will remember. Will not. Words.
Is this working also on sentences?
So currently we've boiled it down to just that cross-language word association pair.
I think there has been studies, from Purple and other people that show that certain frequencies, especially gamma and beta frequencies, account for fusion of words into sentences, so that they delivered a stimuli, a set of Mandarin words, without telling the participants where the words are parsed. And if you present Mandarin words to me, or I don't know if you know Mandarin, but it's the brain doesn't parse it in a correct way, because we don't know which syllable belongs to the previous or the upcoming word. And that linkage in the brain is formed by beta gamma coupling oscillations. And it would be interesting to see apart from oddball, right, to see an evolution towards more complex paradigms where you can test sentence formation and understanding.
Huh. Yeah, that's already got the cogs working. And my background is, which I didn't talk about so much, is computational neuroscience from an attention perspective. And so this is something my brain readily understands. But yeah, that ability to differentiate syllables, that definitely seems like an entry point for stringing together sentences within the framework.
How about I drop a link here in the chat? This is amazing work. Actually, I'd like to learn Mandarin, because I think it's going to be useful if you travel to China. This could be a very useful tool.
Yeah, 我说一点中文. I speak a little bit of Mandarin.
Amazing. And then for our speakers that don't understand Mandarin, what did you say?
I said I speak a little Mandarin.
That's great. Is that true? Is anyone that can confirm that here?
No, I just made that up. Anyway, this I didn't demo live. It's a little more finicky because it's hot off the press. Essentially shows that we're making a classification in real time, and if my video would work, here we go.
Did you learn Chinese from your app?
I mean, that would be a really good sales pitch, but no. I've used my Mandarin learning to make the web app, at least in part, to structure the stimulus. Actually managed to get my Chinese language teacher, who's a linguist, to come up with the stimulus for the second study. So I have like proper linguist approved stimulus.
So meanwhile, while you're explaining your learning and then your experience and then consultancy with your teacher, we have the learning paradigm running in the background, which was actually quite amazing, because you have an ideogram on the left and then the corresponding English word on the right, and you have to say if the correspondence is true or false.
Yeah, so there the value we were returning was just the output of a model that's making the prediction of remembrance at a later time point. So this is that like feedback, the last stage of the BCI pipeline that I demonstrated.
Understood, but do you also record the brain while you do so?
Yes. So that's derived just directly from brain data. That's the input of the model.
And the input on the linguistic side is Chinese or English?
There isn't one. Well, we don't actually care about the specific word association pair. we're just saying we made this classifier derived from hundreds of individual trials, and then in a binary fashion, are we going to remember this particular
Understood.
association?
So it's an offline classifier that takes your brain data and the linguistic data and then pairs them and then comes up with the weights of a binary classifier.
So this one's actually live, running through Google Chrome.
And you have surrogate data that you are running through Google Chrome to run the classification and the training.
Yep, it's all done client side in real time.
Understood. So would people be able to run this with a simple browser, allowing that they have Koala Academy with their OpenBCI device?
Theoretically, we're validating with like 144 hertz monitor, so like technically we can't say anything outside of that context, but that's kind of the goal, is to provide open access, browser-based, enhanced learning.
Understood.
Yeah.
And if you'd like me to ask, or you want to finish your thought?
Oh no, go ahead.
This is really interesting. I was thinking if the classifier is based out of a single person's brain activity, or if it's based out of multiple persons' brain activity.
Yeah, certainly. The latter would make for more interesting models, but right now we're just working with individualized models.
It's interesting. Yeah, we know how difficult it is to acquire EEG data that is consistent across different individuals, because the foldings of the brain and their projection onto the scalp and the form of the scalp, the curvature of the scalp, they're all different. So the electrode sits differently, even if they are in a 1020, montage, they will sit differently on different heads. And that's already, a principal acquisition conundrum. But I would imagine that you could use some transfer learning once you solve that technical problem of the, different recordings.
Yeah, and that's even within like low-hanging fruit research, showing like there's consistency at home of one person trying this and getting consistent, reliable signals across time points.
That would be amazing to run a longitudinal, learning, long-standing experiment to see your progression in your Chinese Mandarin learning routine.
Yeah, I mean, down the road, I'm trying not to think too many steps ahead, but as you'll see, I've kind of already failed at that. Yeah.
This was quite clear.
But yeah, the research trajectory might look something like this. We don't have, I think, probably not enough time to go too much into detail. But in case you're interested, here's a broad layout of the upcoming language learning study. This is after the oddball. So this slide depicts that creation of the individualized algorithm from a given user's brain data at time point 1 and behavioral data from time point 2, and what the trial and blocks would look like. And then this depicts a means of internally validating the model's ability to predict learning outcomes. And again, trial and block construction there. Sort of getting into the territory we're talking about of looking at an individual user's signal quality over time. Right now, we're validating with reinitializing the last 2 indexed EEG channels into EOG. But of course, that's more setup time. And so I quite like the prospect of removing the necessity of EOG by validating live EEG-based eye artifact removal within Koala Academy, within the framework. And so, yeah, that would make setup time quicker. And yeah, we've been playing around with implementing real-time enhanced automatic wavelet independent component analysis to pull out eye-specific artifacts and other artifacts.
There is a comment from Richard Waldman from OpenBCA that you can use the ThinkPulse active electrodes.
Yeah, that was my next slide. Here's the ThinkPulse active electrodes. So yes, I got a full headset of them right here. So there's a few hiccups in validating. I'm certainly not paid by Conscious Labs in any way, but like their product and would like to use it in a research setting. So if you recall on the Oddball demo, we did have a checkbox for using the active electrodes, and so that just reinitializes the board to work with them. Yeah, we have a couple project-specific sponsors, Branchout and OpenBCI. Yeah, just a shout out to them. And then this is kind of like the big, well thought out project presentation. So the next couple of projects don't have as large a teams working on them. So I don't have as refined assets. But this seems like a casual ordeal. So yeah, this is Bermuda. It's an open source project, full stack, looking at simultaneously collecting research grade, synchronized eye tracking, body tracking, and brain data. And we're trying to do it for under $1,000 with a reasonable frequency. Yeah, so we're doing all of that in Python. We're developing our own in-house EEG. So we have senior E students or electrical engineering undergrad students. Yeah, we recognize the utility of OpenBCI's boards. We're currently using a Cyton in the prototyping stage, but just to like increase our internal knowledge base, and yeah, being able to pick components at the hardware level. Yeah, we're doing some stuff in-house. So this looks at 8 channels is what we're working on at 1,000 hertz. This is our first major iteration. We've changed some components since then. Yeah, and then we're making bare bones eye tracking using a Raspberry Pi, a couple cameras.
Is it based out of infrared or visible lights?
It's infrared for the eye tracking camera.
What's your accuracy?
Oh, I'd say out of all the different components, eye tracking is like probably the farthest back. So I don't have like solid metrics on accuracy yet. We're just finishing up our calibration right now. The goal is to like take a step back and build everything from the ground up in a way that we understand it and can validate, and it's all in Python, and it's easy to change because our goal, kind of dropping it early, is we're going to open source the whole thing.
Interesting. And what will be the sampling frequency, frame rate for this camera?
These ones were working with, I believe, 60 or 90 hertz between the two. So yeah, nothing too crazy.
But ideally, if it's open sourced and it's hardware independent or platform independent, it doesn't really matter. You can substitute the hardware and have it at 20,000 hertz, and it's going to be working.
Yeah.
Thank you for this contribution.
Yeah, it's been fun. Next we have the incorrectly labeled eye. It's actually body tracking, and so here we use a Raspberry Pi and a stereo cam external module that feeds into the Pi, and we're playing around with a TPU coprocessor. So the one we got our hands on, despite the chip shortage, does 4 trillion operations per second, and so that equates to we can have 30 hertz of real-time hardware accelerated classification of 12 body points.
Oh, so that tracks
3D, in 3D space.
It's sort of if you like, body tracker.
Yep, it's sort of like a hacky body tracker.
12, you said?
Hacky, like we hacked it together, but our hope is that we can validate it to the point where it can be used in research and it's cheaper.
And this sorry to interrupt, but it's very interesting. So these are cameras in the visible spectrum, right? Visible light.
Mm-hmm. Correct.
And you have a 30 hertz frame per second. 30
20. Yeah, that's our theoretical max when it's wired. Right now, for development, we're mostly using wireless when we can send that to the central computer at 2 hertz.
And can you decide the points on the person's body that represent the fiducials?
Representative of.
So if you acquire the body of a person in 3D, and I believe you said you can use from 10 to 20 points on the person in 3D. Can you choose what points to use, or is just in a construction of your algorithm?
I see. Okay, yeah. So sorry, might have misspoke. We're getting if we're doing it wirelessly, we get 2 hertz as our ceiling, and then with a wired Ethernet, our theoretical ceiling is 20 hertz, and that's the output of these 12 joints labeled in 3D space.
And these labels are coming from, your decision of labeling like that, or is there a model that you train to have those labeled?
So that's just like a ready-made model. I'm blanking on the name of that one at the moment. Not sure what we landed on last.
It reminds me a bit like of the iPhone technology for face recognition. If you know what I mean.
Yeah, so we're essentially grabbing both camera feeds and then classifying the joints on both of them. And so yeah, that part is pretty well it's a well-trodden path. And then we pass that back, the points back to the Pi, and then there we like triangulate the joints from the 2 camera feeds.
Understood.
Yeah.
This is a pre-trained model that is used for face recognition.
Yeah, for body joint labeling.
Interesting. Yeah.
Can you tell me what is the applications that you have in mind here? Like, is there a particular, because you're measuring the EEG and you're doing the eye tracking as well. So is there some particular paradigm or like experimental result or type of, research kind of approach that, makes use of those technologies that you're bringing in? Like it's not most things you would do with EEG, you would want people to be sat still, right? So again, I'm pretty sure you have some specific ideas, but could you elaborate?
Exactly that. We don't want to be sitting down and constrained. We want to have high resolution understanding of the participants' body joints in space, and where their eyes are, so we can regress out artifacts. Like, to me, that in itself is like the first major application of this. Yeah.
It's very interesting. And I guess you could maybe drop later on in the chat here the name of the pre-trained model that you leverage to do the classification at some point.
I would say definitely Rehab is a natural area for this, right? So like there's like when people are having rehab for motor rehab, if they've had a stroke or had a car accident or something, then
yes, I don't want to get too much into that because the next project. But yes, on the surface would be good for isolating actual brain signals from participants interacting in more interesting ways in the environment, in the research environment. And then, that was our initial thoughts. Our thoughts beyond the initial applications would be within rehab and kinesiology.
Nice.
Interesting. Very nice.
Yeah, and this just quickly demonstrates some of the points being labeled. This is just at 2 hertz transfer wirelessly.
It's amazing that it works at such really compelling lighting situations in the room, because it might be a lot of interference from the lens, but it doesn't seem to affect the algorithm.
Mm-hmm.
Even when you point the camera at the lights.
Yeah, we can't take too much credit for doing that piece, because for the most part we just applied a pre-trained model. The funner parts, and the ones we can take credit for, are just playing with the hardware and hacking together a relatively low cost solution.
It's amazing.
Yeah, so we have a couple project specific sponsors for this slide. Want to shout out the undergraduate research initiative at the U of A, and then a makerspace called The Shack, also at the U of A. And then, yes, in Rehab, we have the next project. This one's just starting out, called Open Stroke Rehab. And a little different from both the other ones I talked about thus far. Here we're locally training a model to classify motor imagery as a proxy for intention to move. And then in full stack Python, the goal is to have an ongoing classification, and if we get that classification above a certain accuracy, then we wirelessly stimulate their nerves in their arm or other appendage, and then just threw in some TDCS preliminarily.
And what is TENS?
So that's transcutaneous electrical nerve stimulation. So that's just peripheral nerve stimulation. So the prototyping goal with this one is just a little Arduino BLE circuit that passes a direct current through 2 muscle entry points.
That's interesting. And this is you're using. You mentioned a motor imagery protocol. Can you spend 2 words about that?
Yeah, I certainly not my area of expertise, coming from like attention. But this project and its feasibility kind of stems from that being a solid, well-trodden path. We're going to have some custom solutions to make that more effective. We're going to be modding the Ultra Cortex to cluster electrodes about the primary motor cortex, so we get a better resolution without having to do anything from the ground up.
Yeah. And the Ultra Cortex, for the audience, is that device that you showed before, which is your electroencephalography device, acquisition device from OMBCI.
Yeah, so the Ultra Cortex headset is like the 3D printable headset unit, so we can create our own customization and test it out within a couple days.
So Eden, with this, so, by the way, this is very cool, and this is actually kind of stuff I'm into, you know. So and I think you're right. The electrical stimulation in the nerves, the sensory stimulation in rehab, right? That is like one of the more developed areas in terms of using brain stimulation based BCIs. So, but the question I have is like, what is the current status on the delays and the lags in these circuits? Because that's the thing when you're doing real time, you know, like you need to have all of the software and hardware components being super quick, and it depends on what exactly you're doing in terms of the brain events that you're trying to trigger to, whether what level of precision you need. But in general, like these electrical stimulate plus a brain response setups, like you're trying to induce plasticity. So you're kind of talking about trying to get essentially 2 action potentials coming from different locations to arrive at the same time, and there'll be probably 10 milliseconds or so of like leeway in that max. So what's the deal with like delays in the circuits? Like have you evaluated that systematically? Do you know how much of an issue or kind of a challenge that's going to be?
We're still hacking together an alpha on this one, but we're fairly like low level in how we're communicating to the Arduinos from a Windows machine, and so we're comfortable with like using multi-processing to parallelize the GUI and any aspects there, and so. Yeah, I haven't actually worked with pinging Bluetooth in a while now. That is a good question. I don't have the answer right now.
Do you have a link to this project?
Yeah, I have a link to all of the projects.
Potentially one of the things you might be able to do in this setup is to factor in the delays, because you will have some delays from the Bluetooth and the rest of the circuit. But if you're kind of in a context where you're looking for a motor cortex brain signal that is indicating the preparation of the movement, but that's coming, right? Like you've basically told people to do that. then
Yeah,
you have
it would
a little
be
bit of
predicated on like very early detection of that waveform indicative of movement. So yeah, kind of balancing the strength of that prediction with how quickly we can predict it.
yeah, but you expect the movement to be happening, right? Like you're in a context where people are going to be doing that. It's not like a completely freeform, or at least that would be one of the contexts that you'd be in. So my point is that if you're in a context where you know that someone's going to be moving at some point soon, and you know that that brain signal is going to be coming at some point soon, then you can have, I mean, for example, very high false positive rate leaning algorithms that are like very quick, or I can imagine other ways that you can kind of, counter the fact that the circuit will have some delays. But I think that I really would encourage you to check out the what the like numbers that people are working with. So one example here that's related that I'm a little bit familiar with is real-time phase estimation for TMS EEG. And the what people want to do there is they want to take a rhythmic signal, and they want to from the brain, like your alpha rhythm, so 10 hertz signal, and then find when the trough of the phase is, and then send your TMS pulse when the trough of the phase is. And because brains are noisy and variable, it's not just a purely sinusoidal waveform, like it's a noisy oscillation. So it's like, but it is predictable. But you need in that context, right? So like that context, they have certain it's half of that period is like roughly the leeway they have for getting that right, or even like less than that. Like they really want to hit the trough. So
yeah, around 4 to 5 milliseconds.
Yeah. So and you have to do it in advance. So it's just like you need to predict the phase in advance. And what it boils down to is they find that, like, I think the general picture is that they need to have real-time phase estimation with like 1 to 3 milliseconds precision, phase estimation in the future, like 1 to 3 milliseconds ahead, and that needs to be operating in real time. So I think these questions around what the delays are needed and what kind of level of temporal precision are needed for different problems. Mm-hmm. These are things that in some cases they've been like worked out, and it's worth trying to find the people who've like done the numbers to figure out what precision you need for your specific context.
Yeah, and I'm not unfamiliar with like alpha entrainment and introducing stimulus at certain phases.
Yeah.
Of alpha.
Yeah, I guess what John is pointing out is that having the timing right might be part of a limitation of the hardware, as well as the connectivity and Bluetooth connectivity. So you have to work with timestamps that are generated at the Bluetooth device level and then broadcast. All these kind of nice timing issues that we encounter in hardware development, as you know, right? So it sounds really, really interesting, and having a low-cost solution that is accessible and allows people to work on these topics is really amazing. Thanks for your contribution.
Mm-hmm. Yeah, and we are, as soon as we do have an MVP, looking to open source it with the appropriate caveats of saying we're not responsible if you shock yourself a little too hard. But
matter of fact,
yeah,
I was looking for it.
Yeah, and I've worked, and even with like Qual Academy, I'm familiar with like sub-millisecond synchronization. Granted, that is wired.
So there might be a lot of interest here from the audience. So if somebody reaches out and I believe this is an ongoing project, then you will be in touch and available for inquiries.
Yeah, absolutely. Even on our website, our webpage for this project.
Yeah, I was browsing before, but I was clicking on on the project itself, and I found the OpenStroke Rehab, but I haven't found a specific link to a repo or other links.
Yeah, so we're gonna wait till we're a little more further down the line before we open source it, because we're making our own like 10 circuit. We want to make sure it has like appropriate safety considerations.
And that's a big project, right? So many components, many moving parts.
Yeah, that's what makes it fun.
Definitely. Would you like to wrap up the presentation and then show us the final credits for this OpenStroke?
Yeah. There were a couple ones I can skip over. Rimbrain makes some art from brain activity. It's customizable at different events. We're dropping it in spring 2022. Here's a side project I did. I got a whole spiel on it. I don't know if I have time. Do I have time for a 2-minute spiel on this slide?
Sure.
Oh, okay. It's just funky, so I like focusing on it. Yeah, this is a proof of concept.
Can you please keep playing the video while you're talking?
Oh, yeah.
Because I was enjoying it.
Yeah, this is a proof of concept combining EEG and eye tracking in a virtual world. So each orb corresponds to an electrode on a 16-channel headset, moves in synchrony with users' real-time brain activity. The pink 3-dimensional vector is for gaze and indicates where the user's looking. And the user, when they look at a given orb, a little audio stream representative of the brain activity underlying that sensor is played, as well as some text prompt above the head is specific to that sensor is displayed. And so it was in an art gallery, so I tied it back to art in saying each of the text prompts is loosely related to consciousness as it pertains to the underlying area of the brain. Yeah, so that was, and that was in a downtown gallery in Edmonton up until a week ago. Just more shit thrown at the wall, but that's what I like. Yeah, and then we're expanding. We being NeurAlbertaTech, shifting to supporting external project teams with the help of some of our innovation-focused collaborators. And we aren't mandating any donation of equity. We're just trying to bootstrap the ecosystem here. And yeah, we're entirely volunteer-based, but we've had a lot of significant support from companies all across North America and Europe. While we continue to expand, our focus is maintained as a high-quality professional development opportunities. Yeah, and we wouldn't be here, anywhere near here, without all these sponsors. Yeah, that's NeurAlbertaTech. That's some of what I do in a day. Yeah, and although our primary focus is Alberta-based innovation, first and foremost, many of our programs, including the workshops, speaker and networking events, and competitions, those are open to people outside of Alberta and abroad. And yeah, that's me.
Thank you. And there is a toast to your great presentation and the breadth of your expertise and the applications that you develop with your teams and that you're leading, and then you're showcasing today in NeuroTechX Showcase applications, hardware and software. So thanks a lot. Great work, Eden. I thoroughly enjoyed the presentation, and Not to mention the fact that you're working with stroke patients, or you're planning to, and also you're collaborating with Thinner Labs, that is also a hub to solve problems for multiple sclerosis patients. So thanks also to your sponsor and sponsors for having this in place, and for your mission and vision.
Yeah,
I'm looking forward, actually.
Yeah, I don't plan on stopping anytime soon.
It's a long ride, and I appreciate that. And I'm looking forward actually to a couple of links on some of the applications that I've seen that are very interesting and are related to also what I did, what John does, and many people here around the community do. So we like closed loop applications, and then I see that you're working a lot with that. The mentoring application and the TDCS and nerve stimulation applications are amazing. And I would have liked to know more about the art projects, but for the sake of time, time is a tyrant, and then we have to yield to that. But I think the audience, and me included, thoroughly enjoyed your presentation.
Yeah, thank you very much for having me.
Yeah, this is really great. I mean, so much good stuff, hardware and software as well. And I'd love to follow up on the JavaScript, on the hardware. Yeah, lots of things. The art is cool as well.
Awesome. Yeah, my door is open.
Thanks a lot. And
in Edmonton, we can grab some beers.
Always ready.
Noted. Same for Toronto, and Ori can testify to that being the case as well. Mostly welcome, Eden. I don't know if you're happening to be in Toronto anytime soon, but mostly welcome. If you can drop your contacts in a chat, would be great for the audience for future, because this is going to be shared anyway. So I'd like to close and wrap up the event tonight. It was a great evening with great guests. Oren, Eden, thanks a lot again. And I'd like to meet again in 2 weeks for everyone. And we will have Frank Russo from Ryerson University here in Toronto, and he will present his applications for the NeuroTechX Showcase. So I see you all in 2 weeks. Frank Russo with John and Chris. Looking forward to see you. See you guys.
Good night, everyone.
Good night.